Our next example is going to consider this reaction where nitrogen dioxide combines with carbon monoxide to form nitric oxide and carbon dioxide. This one has three-step mechanism, two of them that are fast and one of them that's slow. So when we go to determine the rate law for this proposed mechanism, all we are going to be focusing on that slow reaction because that's the rate determining step. So the first thing we will do is we will write a rate expression that only involves K2 and our N2O4. Then once we're done with that, we'll realize that N2O4 is not part of the balanced equation, and we will need to set up some rate expressions to solve for the concentration of N2O4 in terms of other components in the equation. And part B of this question says, is the rate expression consistent with the mechanism if experimentally determined rate expression is the rate equals K times NO2 squared? So we'll determine the rate law based on the mechanism, and then we'll compare it to the rate law from the experimentally determined version. We're going to look at the same expression, and now this time we have two fasts and one slow. But we only need the slow reaction because that's the only rate determining step. And it doesn't matter whether it's first, second, or third in the order. So our fast reaction only involves the rate constant K2. So our rate expression is going to be K2 times N2O4. But just like our previous example, our N2O4 is not in our balanced equation, so we need to set up a new set of expressions that will involve our concentration of N2O4. So we see the first reaction, the equilibrium reaction, has K1 times NO2 squared, and the other one is K minus 1 times N2O4. These two expressions can be set equal to each other. And now we have the ability to solve for our concentration of N2O4. As we did in the previous one, put all of the other components on the opposite side, solve for N2O4. And so when we've solved for N2O4, we get K1 over K minus 1 times NO2 squared. And then when I plug that back into my original K2 times N2O4 expression, I get K2 times K1 over K minus 1 times NO2 squared. And the second question asks, is that verified by looking up the experimental expression that says that NO2 is second order? And this does verify that NO2 is second order. We rely on NO2 squared as part of our rate expression based on the mechanism, and then it's also verified based on the experimental expression that was given in part B.